What have I done? But this one is living here. And what current is living here? The current that is actually living here. Shit. Hope this hope this doesn't affect our answer. It should have been this way. I know that yes, on the inside, current moves from the first node to meet the second node. But notice that the outside, I also told you that the outside, the voltage determines the direction of this. So current enters from this to this place. I just hope it doesn't affect our answer because this means that V2 is actually higher than V1. God, I hope this doesn't affect our answer. So this should be V2 minus V1 all over 2. That is this and this in between this. While this I4 now, yes, I4, if this is moving from here and coming out here, simply means that this should have gone like this. Ah God, what did I do? If it's entering from here and going this way, it should have gone this way now, since all of them are going to the ground. Then this will move to come to the ground and to meet this node. Yes, on this side, it moves from a node to another node, but on the outside, the voltage is determined. So notice that all these ones now are being carried from the outside to this, while on the inside, so I just hope it doesn't affect our answer, but if it did, we have to resolve. So this is the diagram. They said in this circuit, we are asked in this circuit to find the current in the 5 ohm resistor. So please, you can take your time and draw it or pause the video. When you finish drawing, you now continue with us. So this is a voltage. Positive terminal is bigger, negative terminal is the smaller side. And I want you to know, in our physical class, I told you that current moves from positive, then leaves through the negative. So it simply means that here, current on the outside. So the principle is to always note that in doing Norton's theorem, the current outside moves in accordance to the voltage. So current will be moving this way on the outside. Sorry, current will be moving this way, that is, it enters. I know that we have this mindset of moving from positive to negative, but when it has to do with a circuit, it's the same thing. Current enters through the positive terminal and leaves through the negative terminal. So it's moving this way, current is this way on this. Then here, down here, current is entering through the negative and leaving, entering through the positive and leaving through the negative. So on the outside, you obey. If you see voltage on the outside, you obey this. Then whatever circuit you have, whatever resistor you have on that part where they talk about the 5 ohm resistor, we are short circuiting it, so it becomes a wire. Short circuit means wire, open circuit means it becomes open. So short circuit means it turns into a wire or closed circuit. Now the next thing is to find the nodes. And I told you voltage source like voltage, ammeter, resistor, name it, they mark the beginning of a node and they also mark the end of a node. We know that we normally define node as point where 2 or more wires meet or allows current flow. Y junction is point where 3 or more wires meet, allowing current flow. But I want you to know that in basic drawing, circuit drawing, you don't just call it wire. You determine it using the sources, where sources allow currents to be resisted or to move or to be carried. So if that be the case, let's draft the nodes here. So I have a voltage on this. This is a voltage. This one is going to be plenty because I can see that the nodes in this, they are too much. So let's do it. That's why it's academics. So I see this. I see a voltage. This marks the beginning of the first node. So see, resistor ends it. It started with voltage. So you do the up node first before looking at the down one, so you don't put yourself into trouble. Now I see that from here starts another node. So I see that I have a resistor. I have a resistor on this. It moves, and as it's moving, there's a resistor this way, which is 3 ohms. Then I have 2 ohms on this. Okay, I want to demarcate this, please. I want to differentiate so we don't make mistake. So I now move. As it's moving, it comes here and it finds another resistor. This time 2 ohm resistor. Then it moves again. Then this is 2 ohms resistor. This is where it will stop. So it started with a source, ended with a source. These ones inside are like resistors inside, and it didn't pass it. It can't pass any source it means. Once it gets to a source, it stops there. Now on this other end, we see that this is the starting of something new. Another node moves, then comes here, then. So this is our third node. So for the up part, we have 3 nodes up. Then down here on the down axis, we can see that we have voltage starting something. So let me differentiate this. Okay, voltage starting this. Voltage starts it runs, then meets a 2 ohm resistor, and before meeting this 2 ohm resistor, it tried to move up, then having 3 ohms resistor. This is the next node, the 4th node. Then the 5th node, the start of something new. We have this, then moves up. This is 2 ohms. This is 2 ohms. Then it runs, then comes this way, meets 10 voltage source. So this is to show you that we have 5 nodes in total. We have total of 5 nodes. So these 5 nodes, we will start with this one. Let's call this one node 1. We represent it with the voltage. Voltage 1. This is voltage 2. It's the same thing with what is here. This is voltage 3, node 3. This is voltage 4. It's the same thing with what is here. So node has the same voltage. This is voltage 5. Voltage 5 is the same thing. So I'm not going to clean this. That means we are going to make use of this small portion to solve this question, because we keep referring back to this. And remember, I told you that on the inside, on the outside, voltage determines the direction of current. While on the inside, what determines the direction of current is simply the first node we give to the second, the second will give to the third will give to the fourth, and the fourth will give to the fifth. Whichever one is on the ground, all of them are trying to give so that they get to the ground, because the ground is the lowest potential. So let's start here. This is the first node. It's going to give to this. Now this is the second node. So let's do it here. It's giving here, and this same thing that I have here, which is 2 ohms, is what is here. So this 2 ohms is going to give to this one, and giving to this one is not going to go sideways. It's going to point down, going towards ground or towards the third one. This same one is V2 as well. It's coming here. Then this one that is here. So if you are, it's either it's going up when it's vertical or down, and either going left or right when it's horizontal. So this one is going this way. Now the third one, this is it here. So it stops here. This is the same thing here. So now on this end, remember that this is what we have here. This sheet is the same thing that is here. Now this sheet, this particular one, this resistor is the same thing that is here. Sure, you see this one gamma is fixed on it like steady, because it's not something you want to mess with. So this one points this way, comes this way, and that is this one. Is the same thing with this. Is this one. So if I've noted it, now the ground one, which is this one, is now going to be in such a way that we are now going to ask ourselves, what should we use as our ground source? And notice, our ground source is going to be, it can't be here because there's something here. Our ground source is going to be in between this or this. But notice that this particular one is entering here and going this way, while this one is coming down here. So our ground source, we take our ground source to be here, and that particular position is in node 4. That means that everything about V4 is 0. This is 0. We can't do any equation for this V4. V4 is 0. Ground is always 0. So that means we are going to have just 4 equations in order to solve this. The fifth one is 0. We've taken it to be our ground. It was in between these two to form our ground. But we can't use this one to form ground because current is entering here. From the voltage, I told you outside determines the voltage. Current is leaving here. So this is the right place to use. It's not an assumption. It's not how do I want it. We could have done how do I want it assuming there was no resistor here. But in this one, it is definitely going to be this side, because if you check, this is moving inside here. So now that I've noted this, the next thing is to label our current. This is I1. Node 1 we have I1. So it's the same thing that is here, I1. Now this is node 2. So this is I2, and it's having more than just 2 resistors. So this is I3. Don't say because you have it in 2 places. So and it's in node 2, it's now going to be I2. I know. So this is I3 inside node 2. Then and notice this one is the next one, which is I4, and this is the same thing. This is the same thing that is here. I drafted it in this way so that it will be easy for us to be able to analyze it. So this is our I4, that's same I4. And remember, this I3 that we have here is the same thing with what we have here. Is it not? It is. Shebi? Yes. So this is our I3. And if this is our I3, and check this out. We have this. This is our I2. I just wish you can open your eyes and see something. Be seeing it. Don't go and confuse yourself or try to start doing, why did he do it like this? You must follow the way I'm doing it. It's years of experience, so key into how we are doing it. That's the easiest way in order not to get confused. So since we've gotten up to I4, that means the last one. So let's draft this thing as we are doing it here. Let's be putting it here so that it will be clearer. So this is I1. This is the one that gave us I2. That is current 2. This is the one that gave us I3, current 3. I know your mind, when you are starting out, your mind will be telling you, why is he choosing one direction? Is this current not supposed to be flowing this one, flowing this one, flowing this way? If you do that, you'll be disorganized. At the end of the day, no matter how it flows, what determines the final flow is the region of higher potential. Moving it from region of higher potential to region of lower potential. So this thing is more like, after however disorderliness it has on the inside that wire, the push that will definitely be the end push is going to be determined by higher potential, the region that has higher potential, because current moves from higher potential to lower potential. So that's what I'm giving you. That disorderliness that you are starting out with in your imagination of what is happening inside the wire is there, but at the end of the day there will be a direction that the current takes, and that final direction is what we are giving you here. So then I have this. Then for this I2, this particular one is the same thing that is here, which is your I4. So that means it leaves us with this one to be the last one. And notice, since we've taken this to be the ground, that means that this current will be moving this way to go and meet the ground. So I5. Someone could have said, why didn't it go this way? Disorderliness, it will be moving this way as well, but the final push will tend it towards this end, to the ground, to the region of lower potential. So now that I have this is the analysis of how our current is moving, the circuit. So once you've gotten this, so the first principle is to do what we've done. Draft out the nodes, get out the nodes. Know that if you have 5 nodes, your equation will be 4, because the final one will be your ground. If you have 3 nodes, your equation will be 2, because the last one is going to be your ground. If you have 20 nodes, you are going to have 19 equations. Don't say, is it possible? Yes, because this is an electrical engineering course. When you hear an engineer say, I did circuit diagrams, I drafted diagrams, I had to do construction of the building with my circuit diagrams, this is simply what they do. So it can be even more than 50. At the end of the day, what you're expected to have there is like 49 equations. So now going by this, we are now going to apply Kirchhoff's law. Applying Kirchhoff's law is simply current inside equals to current outside. And if you're doing it, anything that has to do with Kirchhoff is also the same thing as saying if it's entering, let it be positive. If it's leaving, let it be negative, all equals to 0. So let's check for the node 1, what is entering? Node 1 now is supposed to be having I1 inside, but notice something. Between this, let's say this is our V1 now, Shebi, call this V1. Is this not V2? Everything here, we said everything here is V2. Follow me. Everything here is V2. Then everything here is V3, Shebi. Then this is V5, you agreed. This is also V5, you agreed. Why this one is that V4, you agreed. I'm not doing anything different. This is also V4, but we've taken it to be ground. So ground is for V4. So now that you know this, so between V1 and V4, so for node 1, I will just do node 1. For node 1, remember you need to be writing this out as I'm doing because we have just small space left. We can't clean this part. This will guide us. So for node 1, I'm going to be having V1. Okay, first of all, for node 1, the current entering, I could have said current entering and current leaving, but before I do that, I see that there is a voltage in between. And I told you one time that anytime you have voltage in between, is the same thing as saying the one up and the one down, where it is moving to. So minus V4 is equals to that voltage given 7V. So it's the same thing as saying the voltage here and the voltage here minus it is equals to what is in the middle. I said it before that if you are given a voltage in 3 places, one up, one down, one in between, that the voltage up, if you notice that the direction of your current is going downwards, that the voltage up should subtract the one down, it will be equals to what is in the middle. Assuming the one down, that you're having your arrow to be pointing upwards, it will now be the one down minus the one up equals to what is in the middle. But since this one is having our direction going down, it will be the one up, it's having higher potential, that's what it means, minus the one down equals to what is in the middle. So remember that V4 is 0, so this is V1 minus 0 equals to 7V, which means that V1 is equals to 7V. Let me write it out. I feel we'll be writing out our equations this side. Too bad the board is not as plenty as the one we got in school, but let's continue to manage the space. So this is V1 here is the first equation, 7V, equation 1. Okay, so I will claim. Now the next thing is to say inside this V1, anytime you get V1 as an equation that has to do with voltage up and voltage down equals to voltage in the middle, anytime you get it, know it automatically that you must have a node. You must have a node and a supernode in that axis. So how do you find supernode? To find supernode is to simply say all of this V now, all of this V and all of this V4 now. Let's say I take it out. Let's say I do as if I ignore it. Check what are the currents entering this V1 and leaving V1, and the currents entering this V4 and leaving this V4. That's an equation for your supernode. That's what you call supernode. So let's check. I'll see that the currents on V1, I1 is leaving node 1. Yes. Then yes. Then for node 4, let's go to node 4. Where did we put node 4? This is our node 4. Notice that I2 is entering this node 4, even though it's same. So I2 is entering node 4 plus. Remember, if it's leaving, it's minus. So let's put minus here. Now, this particular I5, this is our I5. I5 is entering node 4 because see, it's pointing to the ground. This one is coming to the ground, going to the ground. Shey, see, don't come and tell me what of this one now? That's why I told you that if you don't do this thing the way I've drafted, you will see it in textbook being drafted out separately like this. So the reason I put it this way is so that you have a conclusion or a summarized category of what you are doing. So this helps. If you take this whole circuit and you are analyzing with it, you will be very confused. You'll be seeing so many currents flowing. So it's best to do it this way. You see that I3 did not enter. There's nothing of a source inside V4 that has I3. So it's just this and this for for node 1 and node 4. So if that is the case, I'll just do plus I5. Everything should be equals to 0. So this is the super node. So using the node 1, you got this. So for the super node, you have I2 plus I5 minus I1 all equals to 0. I put it this way so that the minus will be out. So equals to 0. So that is for the super node. Now let's go to node 2. Hope it's still recording. Okay, so let's go to node 2. So I'm doing this and clearing immediately so that we have space. So now for node 2, come to node 2. You see that if this is our node 2, this is the node 2, the one that has V2. You see that everything on this, I1 is entering. So I do I1. If it's entering plus, if it's leaving negative, I1 is entering. Now, this one is leaving, going to the ground, minus I2. Yes. This one is also leaving the node. This is the node now, node. So it's leaving it and moving to another node, minus I3. Yes. This one, which is here, is also leaving it and moving to, this one is moving to node 5. This one is moving to node 4. This one is moving to node 3. So it's leaving it, so minus I4, leaving it. So all equals to 0. All equals to 0. Now that you've gotten this, so you always be sure, you check it here. You see I5, Shebi is I3. Yes, I3 is leaving it. Notice that this I5 has no, this I5 should not confuse you. The resistor is not connected to node 2. So look at it ahead. So you can now see that this is simply having I1 entering, I2 leaving, I3 leaving, I4 leaving, all equals to 0. Now, to get your I1, you know that I naturally, current naturally is voltage over resistor, over resistance, sorry. So now check, between this I1, where we have this I1, what voltage is it in between? For nodal analysis, don't just consider voltage, consider it as a difference. That's why you call it potential difference. So you see that it's moving this way. That means this is having higher potential than this one. So it's going to be V1 minus V2. The resistance is 2. So I1 is simply V1 minus V2 all over 2. Now minus. So as I'm doing minus, I'm going to be okay, but I'll just take it step at a time because some of you get confused. So for I2 now, this is V2 here, V4. This I2 is in between V2 and V4. You see it? So I'll now do V2 minus V4. That is for the V2 minus V4. And because the arrow is going down, that means this one has higher potential. All over, the resistance in between is 3. Minus. For I3 is in between V2 and V5. And the resistance in between is 2. So see it. This should be I3. Yes. So this is going to be V2 minus V5 all over 2. Don't play. Because we introduce negative sign, we impute brackets, because whenever negative sign comes, any sign between whatever we have there will change. So that's why I'm closing it. Now, for I4, check what I4 is in between. I4, this is I4. This is the current here. It's in between this voltage and this voltage V2 and V3. And because it's moving from V2, because I'm having the arrow going to V3, simply means V2 is higher in potential than V3. So I'll subtract small from big. So I'll simply do minus, should be, yes, minus V2 minus V3, that is V2 minus V3, all over what is in between it is 2. Everything is equals to 0. So so this is question 1, question 2. So let's continue with this one. That is this one. From node 1 we got 2 equations because of the voltage. I told you anytime you do voltage up and voltage down and get between, then you must find supernode. Now that I've gotten this, now let's check V1 minus V2. V1 minus V2. Then our V1 is 7. Our V1 is 7. Our V2 we don't know it. So it's going to be 7. Or let me just do it this way so that we don't get confused. Let me just do V1 minus V2. Then I'm coming. Then let me open the bracket. Minus all over 2, then minus V2 minus plus V4. This will times this all over 3 minus V2 plus V5 all over 2 minus V2 plus V3 all over 2 equals to 0. Equals to 0. So you can now see what you now need to do is to find the LCM, and the LCM here is simply 6. The LCM here is 6. So if that is the case, if this is 6, I want to clean this up part. This one is very serious, real serious. So this is going to be 6 here, is going to be 3 into V1 minus 3 V2 minus 3 here is going to be 2 V2 plus 2 V4, then yes, minus 3 V2 plus 3 V5 into this minus 3 V2 plus 3 V3. If this is come and times this 0, everything is still equals to 0. So if I've noted it, I hope we're not making any mistake. This, negative, this, okay, this in 3, this, okay. So we've been able to eliminate the denominators. So now you didn't write that, sorry, pause the video, go back, pause the video. Alright, now let's collect like terms. I have V2 here, and V2 here. So my another V2 here. Any other one? So I have V2, 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 V2. So how many of it? And it's all surrounded by negative. Negative V, negative 3, negative 2, negative 5, negative 8, negative 8, negative 11. Should be? So I have minus 11 V2. Then this is any V1 again. So no V1. So I have 3 V1 minus 11 V2. Then V3. I have just one of it. Okay, so I have plus 3 V3. Then plus 2 V4 plus 3 V5 equals to 0. So all of this only. Okay, so V5. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So that's it. Then that forms our equation 3. So this forms our equation 3. Hey, okay. Okay, so this forms our equation 3. I'll write it up here and I won't clean it. So this is 3v1 minus 11v2 plus 3v3 plus 2v4 plus 3v5 equals to 0. So this is our equation 2 actually. Reason being that notice that this particular one we got here for supernode is not an equation. It's an equation actually, but we've not converted it because we just indicated that since we got voltage for node 1 to be this, the current flowing on the supernode is this. So this is our equation 2. We'll fall back to this if there's reason. So now let me mark it out. Go to node 3. Our node 3 is this one. Notice that our node 3 is having the same case with this because there's voltage here. So it's the same thing as saying, how is the current moving? Current is moving this way, from down to up, because it enters from positive to negative and goes out through negative. So this is the same thing as saying node 3. We're in node 3, please. I know we are doing so many things, but if you take it gradually, you will follow. Hope it's still recording. Okay. So this is going to be V5 minus V3. V5 minus V3 is equals to 10. What is here minus this? Because it's moving this way. So this is higher potential to this one equals to 10. So let me write V5 minus V3 equals to 10. So this is our equation 3. Equation 3. And remember I told you, anytime you do anything that has to do with node, like voltage like this, quickly do the supernode. And how do you do the supernode? You simply say everything that concerns this, including its voltages, remove it. Then ask yourself, what are the currents entering that V3 and V5 now, and the one leaving it? So you can see that for V3, I4 is entering it. So I say I4, anything entering positive. Now, for V5, I3 is entering it. I3 is entering it. I3 is entering. Plus I3. I5 is leaving it. I5 is leaving it. Minus I5. I3 entering. I5 leaving. I3 entering. I5 leaving. This one is I4 entering. Any other one, that's it. So that's about the whole resistor there. So equals to 0. So I can say, instead of bringing it here, let me just find the equation. I can say that's why assuming is my what's it called, notebook, it will be easy for me to just, assuming I have big space, it will be easy for me to just say the things. So sorry about that, we ran out of memory storage. But see here, let me redo that node 3. So see, let's redo the node 3. What I'm saying is that on this node 2 equation, I'll come back to it, but for node 3, let's analyze node 3 again. I said that if this is node 3, that we are having V5 minus V3 equals to what is in between, which is 10, because this is shows it's going this up. So if I know that, I now said the supernode is simply removing the voltage and everything about the voltage side, what is going inside it. You see that for V4, For V4, where is V4? V4, V3 is V4. V3, I4 is going inside. Ah, God. I didn't know that this. Ah, God. It's going inside, okay. Why? Oh, this I3 is going out and then going inside V5. So since it's the supernode we are judging, it's a plus for it because V3 and V5 they are together. Then why I5? This is I5, right? Yes, I5 is leaving it. So minus I5 equals to 0. So if you check it very well, in between this is V2, V3 for I4. V2 minus V3 all over 2. Then plus I3, V2, V5. So V2 minus V5 all over 2 minus, for I5 is in between V4 and V5, but it's moving from V5, the higher potential. So it's going to be V5 minus V4, and V4 is 0, so just V5 all over 2. So since it's 2, 2, 2, it's going to be equals to 0, and the 2 that you have as LCM will just, so this is just V2 minus V3 plus V2 minus V5 minus V5. So this is going to be minus 2V5, 2V2 minus V3. So 2V2 minus V3 minus 2V5. So that forms our supernode equation for this. So now that you've gotten the supernode equation, you need to know that assuming I have 5 nodes, I'm supposed to have 4 node equations. But notice that I am having voltages left and right. So for that reason, I am going to be having, should I say, supernode for this, a supernode for this as well. So if I choose to come and draw another equation on this now for V5, because I can't do for V4 because V4 is already 0. So for V5, which is the next equation, I can actually say that current is entering here, current is leaving here, entering I3, leaving I5, and then trying to ask myself, what about this? So I always advise my students, have it in mind that if it's 5 nodes, you are having 4 equations. But once you have voltages that touch any part of the node that is not on the ground, find the supernode and then wait it out on trying to find an equation again for that node, because you've already found an equation in the first part of using the voltages and the one in between. So for that reason, I'm going to now have this and then try to see if I can simplify the equations. So let's go back now to simplification. What thing have they do with these cameras? No if you today. This one you start doing. Okay. So on equation 2, I remember that V1 is 7 here, is 7. So 3 times 7 minus 11V2 plus 3V3. Then V4 is 0. 2 times 0 is 0. So plus 3V5 all equals to 0. So this is going to be the same as 21. So if you pull it out, it's going to be minus 11V2 plus 3V3 plus 3V5 equals to minus 21. I need you to know that this equation 2 is this thing, because if you substitute the value of V1 and V4, that is what it is. So now go back to the supernode equation I have here. Let's put it side by side to see if we can get anything from it. So I have this particular equation from the supernode. So I just do the 2V2 that I have minus V3 minus 2V5 equals to 0. So how do I use these 2 equations now to see what I can get for V5 or V3? Remember naturally that when we did this, there is a point where we said that V5 minus V3 is equals to 10, which means that V5 can also be the same thing as saying equals to 10 plus V3. I will always advise you, know this principle. If I have 5 nodes, the equation should be 4 because 1 will be for the ground. But along the line, if I notice that there is a voltage given to me up and down, and I see another voltage in between, and I'm able to note that fact that current moves from higher potential to lower potential, and it will simply be higher potential minus lower potential equals to the in-between voltage. Once I do that kind of thing, find the supernode immediately, so that at the end of the day you don't have to now start checking for another node that talks about current pointing to any of those potentials that has an in-between node. Too much English, but just get the concept. Now see, at this point I'm trying to eliminate. Since I know that V5 is equals to 10 plus V3, I can substitute for it. But before that substitution, let's see what we can do by eliminating. So let's check. If I times this by 3, times this by, yes, let's times this by 3, let's times this by 3, then times this by 1. You know my reason then. So this is going to be the same thing as saying 2V2 minus 3V3 minus 6V5. So I've transformed this one. Sorry, you know I times by 3, this should be 6 now. Minus 3 minus 6 equals to 0. So you times this one by 1. So what I now need to do is to add. Let's add the 2 up. Let's add these 2 up. So simultaneous equation. I don't want to solve it here because of space. So adding up, this is going to be minus 11 plus 6 is 5. Minus 5, Shebe. Hope you are still recording. Okay. 11 minus 6. So this is minus 5 V2. So 3 minus 3, 0 V3. 0 V3. This will cancel this. Please, in fact, now that I transform this, let's remove these sheets so we don't confuse you. So this is what we are working with. So this will cancel this. Now V5, 3V5 minus 6V5. This is going to be minus 3V5 equals to 20, minus 21 plus 0 is minus 21. Yes. Okay. Now remember that V5 is equals to 10 plus. Okay, I think instead of doing that, let's check if there's any other place that V2 has a relationship with V5. Okay, yes, here at this junction. Yeah. Yes. No other place. Okay, so I can actually do. And if I do it, I'm introducing back this. Okay, I think now we are done with this. We are done with this whole okay, but before that, so let's say I go back to the equation where I have this. Okay, this can be the same thing as saying minus V2 equals to minus 21 plus 3V5 all over 5. So, or you say all over, yes. Okay, yes. So if the minus cross over, let me do this way. I have, oh God, what am I doing? I have 21 that is having minus plus 3v5 all over 5. Assuming it crossed with that minus, let's say this is the minus. Okay, yes. So I don't come and be disturbing myself. So if this is the case, let's leave it that way, because I could say this, but it will affect this. So it's the same thing as saying, if you divide by the minus 1, this is the same thing as saying 21 minus 3v5 over 5. But let's leave it at this for now. So v2 is equals to this. V2 is equals to this. So let me write it somewhere here. So if I know this for V2, it simply means that I can come here and substitute. This is the value for V5. This is the value for V2. Okay, I can come back in this equation, any of this equation. Since I know V1, the super node of this, I know V1, I know V2, and I know V5. Is this V2? This should be V2. Yes. So I can come back here and substitute, or I can even come back here. So let's check. So let's say I substitute. That is for super node of V1 super node. And then this is going and then okay, so let's check that one. Let's say I know this is 7, so I have minus 3 into 7, then plus 5. Instead of V2, let me substitute this. So minus 21 plus 3v5 all over minus 5 for V2. Then I have V5 plus 3v5. So that's square root equation equals to 0. I could have done it here as well. But I don't want. Assuming I wanted to do it here, I will substitute for V2 because V2. Okay, no, it will still. Yes, okay. No, let me use one that makes it easier for me. So now I have over 1 is going to be the same thing as saying minus 21 plus 5 times 21, 105. So this is going to be minus 105. Yes, then plus 15 V5 plus 3 V5 So this is over 1. This is over minus 5. This is over 1 equals to 0. So right here, this can be the same thing as saying so 105 divided by 5 This is the sentinel space coincidence. So this is plus 21. 15 divided by minus 5. That is minus 3. Minus 3 V5. Minus 3 V5. Yes. Minus 3 plus 3. Is it not 0? Okay. Okay, minus. Okay. V5 minus 3 V5 plus 3 V5. Okay. Let's continue. Plus 3 V5 equals to 0. Okay. Then minus 21. So minus 21 plus 21, 0. This is 0. So let's finish up here. This is going to be minus plus this is 0. Then minus 3V5 plus 3V5 is also 0 equals to 0. That means this equation we used cancelled or what? Okay, let me just draft here. V2 is equals to minus 21 plus 3V5 all over minus 5. That equation can hold. Come. So let's see. I know that here is 21. This is 21. Minus 11 into minus 21 plus 3V5 okay, all over minus 5 plus 3V3. This is 0 plus 3V5 equals to 0. Okay, so but I can come here and say since I have this V3 here can be the same thing as saying here, right here, where I have V5 equals to 10 plus V3. This can be the same thing as saying V3 equals to V5 minus 10. So I can represent this as so V3, this is going to be 3 into V5 minus 10. This is something as saying 3V5 minus 30. So, hope it's still recording. So 3V5 minus 30. Okay, so let's substitute it here. So I'm going to be having 21 minus minus plus, this is going to be 11 times 21. So plus 231 plus 11 times 3. So plus 33. Okay, but it's having minus here. Minus 33 V5 all over minus 5. Okay, all over minus 5. Then plus 3V5 minus 30. That is for everything that I'm doing. Then plus 3V5 equals to 0. So right here, I can know that this will be minus, this will be plus. So do this is something same. Minus 5, minus 5. So it changes to plus. So this is going to 231 divided by 5. 46.2 plus 33 divided by 5. 6 V5 plus 3V5 minus 30 plus 3V5 equals to 0. So I have V5, 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 V5. And then, so this is going to be something the same. 6.6 plus 3 plus 3. So I have 12.6 V5. Then I have here 21 minus 46.2 minus 30. 21 I have minus 55.2. This equals to 0. So if it crosses equality sign, it changes to plus. So I want to clean this. So this is going to be 12.6 V5 equals to 55.2 divided by 12.6. V5 is equals to 4.380. Okay, it can actually be 81, or just let's leave it at this. So volts. So we've gotten V5 now. V5 is now gotten V5 to be 4.38 volts or 4.4 volts. So now that we've gotten it, to get V3, we'll go back to this place. Go back to this. Okay, we'll go back here. So remember, V3 equals to V5 minus 10. So it's going to be 4, should be? So 4.38 minus 10. So V3 is equals to is a minus, so it's going to be minus 5.62. And remember we said we don't have minus voltage, it just means that we choose the a direction on it, or you say it just means a drop. So it's approximately 5.62 volts for V3. So now that we've gotten that, so I now know V1, V3, V5. To get V2, come here, let's come here for V2. So let me just put it. V3 is equals to 5.62. Can put the minus to show that it's a drop. It's a drop, yes, now. This one moving to this increase, drop. B sharp. So V2 is going to be simply 21 plus 3V5 and V5. Okay, minus 3 and V5 is 4.38 all over minus 5. So let's punch 3 times 4.8. Hope you're still recording. So 3 times 4.8, 4.38. 3 times 4.38. That's 13. And this is minus 21 plus 13.14 all over minus 5. So you see, at that point where we try to combine a node equation with a supernode equation, it didn't work. It gave us everything to be 0. So it can't work. So it's node equation against node equation, supernode equation against supernode equation. That's also a lesson to learn there. So minus 21 plus 13.14. So this is going to be minus 7.86 all over minus 5. This will cancel this. So equals to, now do 7.86 divided by 5. So you're getting 1.572 volts for V2. So we have V1 now, V2 and V3 and V4 and V5. So with that said, I want us to go back here and write all those our equations. So we have V1, let's write V2. So let's have V2 embedded here. V2 is equals to 1.572. Let's have V3. V3 is equals to minus, which is the same thing as 5.67, but I'm putting the minus to show you there is a voltage drop. It means voltage drop. So please, I don't have space. 1.572 volts minus 5.6 volts, while V4 is 0. V4 is equals to 0. V5 is 4.3. V5 is equals to 4.38 volts. So now that you have this, you can just come and input it. So I now have this for 1.57, this to be 7. Then here's my V3, this to be minus 5. Or you say 5.67, so you can just write 5.67. While V5 is 4.38. So if I'm to find current on each one now, so let's clean this to find the current. We've gotten the voltages. Remember that when we started, they said we should find the currents in the 5 ohm resistor, and that 5 ohm resistor we short circuited it is somewhere here. Is around, but notice since everything is going this way, so it should be moving this way, is around here. So IN, that is somewhere here. And notice that everything moving here and coming here. From here, all the currents on this are in series. So some will enter here and continue. So whatever I have for my IN, see, watch. Yes. Since this one is coming here. Let's just check. Let's check. Let's not just do an assumption. So I will now have for I1 and I4. Very important. So I1 is going to be equals to V1. Yes, see now. Yes. It's going to, yes, on this side. On this side, you're going to be moving down. This side, you're going to be moving down. What have I done? But this one is living here. And what current is living here? The current that is actually living here. Shit. Hope this doesn't affect our answer. It should have been this way. I know that yes, on this side, current moves from the first node to meet the second node. But notice that the outside, I also told you that the outside, the voltage determines the direction of this. So current enters from this to this place. I just hope it doesn't affect our answer, because this means that V2 is actually higher than V1. God, I hope this doesn't affect our answer. So this should be V2 minus V1 all over 2. That is this and this in between this. While this I4 now, yes, I4, if this is moving from here and coming out here, simply means that this should have gone like this. Ah God, what did I do? It's entering from here and going this way. It should have gone this way now, since all of them are going to the ground. Then this will move to come to the ground and to meet this node. Yes, on this side, it moves from a node to another node, but on the outside, the voltage is determined. So notice that all these ones now are being carried from the outside to this, while on the inside, so I just hope it doesn't affect our answer, but if it did, we have to resolve. So I4 equals to V3 minus V2 all over the 2 in between. And notice, this is going to be V2 is 1 point. I know why I'm doing that. I want to check something. V2 is 1.57 and V1 is 7 all over 2. V3 is 5.67 and V2 is 1.57 all over 2. I know you might want me to put the minus, but I'm not putting it because I noticed that this, God, I have to resolve this question. It's going to be 0.67 minus 1.57. 1 point. Okay, this one minus this is going to give me 4.04 all over 2. And notice that if I do here 7 minus 1.57, this one gives me 5.43 all over 2. 5.43 divided by 2 is equals to approximately 2.7 is equals to 7 amps. While this one 4 divided by 4.04 divided by 2 is going to be equals to 2.02 amps. So the current here, the current on this and the current on this, they are supposed to be equal. 2 minus V1 and V3. So I think where our issues came is the way we placed this. So the current on IN is just going to be 2 amps, or you say 2.02. So this is our answer. This is our answer. So IN value is 2 amps. So I will resolve this question. Reason being that I'll make another video on this, directing the current properly, because the mistake we made here is that we started. That is another lesson. That is another lesson for us. It simply means that before you start with the inside, thinking about how current normally should move from one node to another, first think of how current moves from a particular source to the reference point, that is to the ground. So assuming we started with pointing this now to the ground, and then saying, okay, since this one is starting this way, I'm pointing to go and meet the ground, that means this one should be like this. Then if we've done that, we'll now come and say this is what is remaining inside. So that means what is remaining inside should point to the next node. And when it points to the next node should point to the ground. So that's the mistake. So it's affected our answer in a bit, but I believe our next example will correct that. Yes.